In this part, we continue to implement the GSSHA model in WMS, where we click Next. The window title becomes Hydrologic Computations. Then we click on Compute Index Mapping Table. In the field input coverage 1, we select land use, and in the field coverage attribute, we choose ID. In the index map name field, we type land use. Then we click on coverages to index map. The types of land uses are determined for the basin of the study area, as we see it here in color. Then we go to the field input coverage 1 and we choose soil type. And in the coverage attribute field, we choose texture. And in the field index map name, we type soil type. Then we click on coverages to index map. The soil type for the basin of the study area is determined, where we find that there are 3 types of soil shown in yellow, red, and blue color. Now we tick input coverage 2, and in it we choose soil type, and return to the field input coverage 1 and we choose land use, and make sure that the field coverage attribute is an ID in the case of land use and texture in the case of the soil type. In the index map name field, we type combine, then we click on coverage to index map. The combined map for the land use and soil type for the study area basin is determined. Then we press done. A window titled GSSHA Map Table Editor appears with several menus, where first we go to the roughness menu, and in it we go to the using index map, and we select land use. Then in index map type we choose a grid. Then we click on generate IDS. A table appears in which the values of surface roughness for the various land use numbers from 21 to 83 have a value of 0. Then we click on infiltration menu. Then yes, a new window appears, and in it we choose a green ambit with soil moisture redistribution. Then we press OK. Then we go to using index map and select combine. Then we click on generate IDS, a table appears and containing information shared between soil type and land use. This information includes the following: the values of hydraulic conductivity which are found in the soil type map, which we entered into the program in the previous video, and their values as we see them now. As well as the value of field capacity and wilting point defined previously, where we activate this value of field capacity and wilting point. Then we make a copy for them via Ctrl C. Then we enter the rest of the values in the table, which are capillary head porosity, pool distribution index, and residual saturation, where we go and click on import table. Then we go to the file titled GSSHA, and in it we select GSSHA.cmt. Then we click on open. The values are added according to the soil type and land use. We note here in the table that the hydraulic conductivity values have changed, and we must re-enter them according to the values we have in the soil type map, as we see here. We also note that the values of the field capacity and wilting point have also changed, and since we have their previous values a little while ago, we re-enter the values by activating these values. Then we press Ctrl V. The adopted values are added for field capacity and wilting point. Then we go to the roughness menu, and we find that the values of surface roughness have been added to the table. Then we go to the initial moisture menu, and in it we go to the using index map, and we choose soil type. Then we click on generate IDS. A table appears in which the initial moisture values are 0.15 according to the values in soil type map, and if the information is available about these values, we can change them according to the value available to us or keep it 0.15 in the absence of information about them. This value of initial moisture is very important in determining the shape of the hydrograph resulting from the implementation of GSSHA in WMS, whereas if its value is low, the infiltration at the beginning of the rainfall will be large, and vice versa. Then we go and click on the evapotranspiration menu. Then yes, a window appears titled GSSHA job control parameters, and in it we choose Penman. Then we tick on seasonal resist. Then we tick on soil moisture depth and choose a value of 0.5. Then we tick top layer depth and set it to 0.3. Then we press OK. Then we go to using index map and select land use. Then we click on generate IDS. A table appears with the information that must be entered into the table, namely land surface albedo, vegetation height, vegetation radiation coefficient, and canopy stomatal resistance. As for the land surface albedo values, they can be obtained by going to the file with the following path. Where we have the PDF file titled ISSurface-userguide.pdf, where we open this file, and in it we go to appendix page 28, and we go to the table A1 seasonal values of albedo for the NLCD 9221 land cover classification system, and in it seasonal albedo values, where the sequence number 1 represent the values of albedo in midsummer, and the number 2 and 3 represent the values of albedo in autumn. Number 4 represent the values of albedo in winter, and number 5 represents the values of table in traditional spring, where we choose from one of these numbers according to the season that we have, let it be number 5 for the land use number 21. According to Anderson, it represents a group land and pasture, where we are looking for this land cover here in the table, and here we have in a class number 81 is pasture over hay, and it is appropriate, and its appropriate value is 0.14. As we see, so we write here in the land use number 21.14. Then the land use number 22 number is 22 according to Anderson, which represent orchards, groups, vineyards, nurseries, where we have here in the table in a class number 61 is orchards over vineyards over others, and its appropriate value is 0.14. So we write here in the land use number 22.14. Then the land use number 31, according to Anderson, which represent herbaceous rangeland, where we have here in the table in the class number 71 is grassland over herbaceous, and its appropriate value is 0.18. So we write here in the land use number 31.18. Then the land use number 43, according to Anderson, which represent mixed forest land, where we have in the table in the class number 43 is mixed forest, and its appropriate value is 0.14. So we write here in the land use number 43.14. Then the land use number 81, according to Anderson, which represent sharp and breast tundra, where we have in the table in the class number 51 is shrub land, and its appropriate value either 0.25 or 0.18. We choose 0.18. So we write here in the land use number 81.18. Then the land use number 83, according to Anderson, which represent bare ground, where in the table we have in the class number 31 is the bare rock over sand over clay, and its appropriate value is 0.2. As we see, so we write here in the land use number 83.2. Then we go to vegetation height, where we would just be entering its value to be 0.25. Then we go to the vegetation radiation coefficient, where we enter the value and let it be 0.5. Then we go to canopy stomatal resistance, whereas these values are found in the following path. In the Word file entitled Soil Parameter Estimates, where we open it, and in it we go to the table 13, canopy stomatal resistance, and in this table there are two fields, vegetation type and canopy resistance. And according to vegetation type, for the land use number 21, according to Anderson, which represents cropland and pasture, where we have in the table in vegetation type cotton field, the value is 17. So we write here in the land use number 21, 17. Then the land use number is 22 according to Anderson, which represent orchards, groves, vineyards, nurseries, where we have in the table in vegetation type grassland, the value is 100. So we write here in the land use 22, 100. Then the land use number 31 according to Anderson, which represent herbaceous rangeland, where we have in the table in vegetation type coniferous forest, the value is 100. So we write here in the land use number 31, 100. Then the land use number 43 according to Anderson, which represent mixed forest land, where we have in the table in the vegetation type coniferous forest, the value is 140. So we write here in the land use number 43, 140. Then the land use number 81 according to Anderson, which represent shrub and brush tundra, where we have in the table and vegetation type irrigated short grass group, the value is 86. So we write here in the land use number 8186, then the land use number 83 according to Anderson, which represent bare ground, where we have in the table and vegetation type unirrigated barely, the value is 43. So we write here in the land use number 8343. With that, we have completed entering the data in the evapotranspiration menu.